Everybody know? Oh, today is a special day. Really. Faux real. That's a very special day. Everybody ought to know that January 8th is Elvis's birthday. I'm just saying. So, yeah. Anybody know that before you came in this classroom? Thank you. High five. Y'all ought to know that. Here we go. Rational expressions. Do you know what a rational expression is? It's just a fancy term for what? A fraction. That's all it is. It's just a fraction. So you know how I like to make connections to stuff that I'm familiar with? I go back and I think about 1/2 times 3/4, or 1/2 plus 3/4, 1/2 minus 3/4. What do you have to do when you're adding, subtracting, multiplying, and dividing fractions? You got to know. That's why it's so important. When do you learn fractions? Like the 4th grade, really, I guess, is when you hit them hard? I don't remember. But I tell you what, I have a newfound respect for teachers who teach this to little children, because fractions it's a tough concept. It's a tough concept for adults, believe it or not. Anyway, it's just a fancy word for a fraction. Here's what you're going to do. If I were to tell you to just simplify, because that's what we're going to do to begin with, and I said, okay, I want you to simplify this right here, 2/4. Then you know that when you simplify 2/4, it's what? All right, have you ever thought, we know, we just know, we know, it's 1/2. But how is it 1/2? You divide the top and the bottom by the same number, which in this case happens to be 2, right? So we divide by 2. What are we actually dividing by? Or, pardon me. What are we actually multiplying by? Dividing by 1. Okay, go on and take pictures. Go on and take pictures. I'm recording, so you're good. Yeah, y'all just go. Don't just randomly get up and go, I'm going to take pictures, and walk the halls. Would that be cool? So we're dividing by 2. We're dividing by actually just 1 in this fancy form. Now, how am I going to apply this to something that looks like this? C plus 5, let's call this example 1. C plus 5 over 2C plus 10. Again, we're in the land of Algebra 2 review, so for a lot of us in here, this is like fresh because we just got finished with this last semester. But what would you do to C plus 5 over 2C plus 10? Now, go ahead, say it. Somebody got ready to say it, I thought. Combine like term. Do I have any terms that are like, that are the same, that I can, the C's are similar. C plus 5, I can do what, Cody? Oh, we're wanting to divide terms within those quantities, aren't we? Christian, is that legal? We've got to find the GCF of what? Of the denominator. Folks, you cannot, you better put this in big old letters, okay? You cannot cancel terms within a quantity. Can't do it. I cannot mark out a C with that 2C. I cannot mark out a 5 with the 10. Tell me why, and this is what I always got last semester. Well, Mr. Harrell told us they were holding hands. And you can't touch them if they're holding hands, right? If I'm holding hands with my man, and Ebony comes up to my man, and she's going to start, I'm like, oh, no, you not. You ain't messing with my man if I'm holding his hand. You a bold woman if you're going to do that, right? Am I right? Those of us with honeys, you know you feel that way. I'd knock somebody out if they come up holding hands with my man, and you, oh, no, no, not happening. Not happening. And that was recorded, thank God. So he really knows that I love him. All right, so Cody, long time ago, 14 minutes ago, said, factor out the, or y'all kind of tag team, factor out the GCF of the denominator. What is the, what's the GCF? 2. Which leaves us C plus 5, doesn't it? Is that all I can do to it? Monomials cancel with what? Monomials. Binomials cancel with binomials. Trinomials cancel with trinomials. But I cannot do this. Don't you dare do it. Do not do it. Don't go C and C. C is part of a what? It's part of a binomial. That is what I'm talking about, a term within a quantity. I cannot do that. Don't you dare do it. But what can I cancel out? C plus 5 and C plus 5. I can cancel those out because a binomial goes with a binomial. Now, I've marked everything out on top. What's up there? Are you sure it's not 0? Why is it 1? Because everything's gone, but if nothing's there, isn't it 0? It is a placeholder, but why can't that placeholder be 0? Because 0 divided by anything is 0. That's right, okay? So, Tiffany, you're right. It's 1. What's left up there? That invisible 1 that's in front of that quantity. So what is our answer? 1/2. And we went over this in Algebra 2, and we kind of touched it. We just have to recognize, what can the value of C not be? We never, ever, ever, oh, like a bad Taylor Swift song. But girlfriend can't sing. She can write songs. She can't sing. What can a C not be? Why? We never want our, there I go again. We never want our denominator to equal what? 0. Why? If the denominator is 0, what kind of term do we have? Undefined. Somebody said it. Oh, here's something you'll never forget. If 0 is, if 0 is under the fraction bar, and we're in Australia, then our number is undefined. So if 0 is ever under the fraction bar, it's undefined. Oh my goodness, Jansen, I saw that. Undefined. You'll never forget it. Undefined. Okay, question. I would leave it, yep, because you're wanting to simplify. Good question. Does everybody understand what he just said? Or what he just asked? Check this out. Example 2. If it said to simplify, that's a good question, Cody. If it said to simplify C plus 4 and 3C plus 15. Can you simplify? You got to factor what? The bottom, the denominator. And it's going to simplify into, what's the GCF of 3C plus 15, everybody? 3. 3 plus the quantity of what? C plus 5. Do you understand now what Cody was asking? If the quantities don't match, what do? You leave it, and we circle it, and we're done. This is simplified. You can't do anything with that. Would I need to multiply it back out? No, because that's when we start chasing our tail. We just keep going around in circles, and we don't get anywhere, okay? That's a good question. By the way, what can C not equal here? No, it's just the denominator. What can it can't equal -5. If it is, then it's going to make our denominator 0, which means undefined. Here's another one. How about this one? Let's ramp this up. A to the 4th minus 3a cubed over 2a cubed minus 6a squared. Always, always, always. Factor and then cancel factors, not terms. Monomials with monomials, binomials with binomials, and so on and so forth. Do I have like terms that I can combine in the numerator? No. Do I have any that I can combine in the denominator? No. Take the GCF out of both. So what's the GCF of the numerator, folks? A to the 3rd. A to the 3rd times what? A minus 3. Y'all cool with that? Somebody over here, what's the GCF of the denominator? 2a squared. What's that leave us? 2a squared times the quantity of? Is he right? Yeah? Lexi, what now? What now? It's factored. Now what? Cancel a minus 3s. They match. Cancel them. Anything else here? Anybody see anything else? Do what? The a's. Bless you. If I've got a squared on the bottom, and I'm going to use a different color because I'm crazy that way, then how many a's would be left on top, Beth? Just one. So what's my final answer, folks? A over 2. Comprende? Why is it 1? Because I got 2 down here, and I could rewrite this as a squared times a to the 1st. So I'm canceling out the a squareds, which leaves me a to the 1st. No, I marked out the 3 because I took 2 a's away from it, which left me with 1. Okay? If the exponent was lower, then I would mark it out and I would come down here. Yeah. Yep. Questions? Comments? Rude remarks? I can take it. Just be ready. Okay? All right, here's another one. Oh, this is a good one. Still simplifying. Daggone, why'd she do that? What we're going to have to do with that numerator? Oh, and it has a leading coefficient other than 1. Yuck. So some of us might have to do what? Slide and divide. Some of you might trial and error that numerator. You guys figure out. Do this one on your own. My squeaky shoes. We have that numerator factored. This one, I can look at it. Sometimes I can look at them and figure it out. Sometimes I can't. If that leading coefficient is prime, I can go trial and error all day long. But if it's not a prime number here as a leading coefficient, that's when I usually slide and divide. Is there a GCF to factor out of that numerator? Nah. So if you go trial and error, that trinomial is going to bust down into 2 binomial factors. What goes? What times what is 3x squared? 3x and x, right? Okay? And then What are the two factors of 3? Well, we got 3 and 1. It's the only two factors we got. I've got to get 10 as a middle term. Where am I going to put the 3? Am I going to put it here in the first set of parentheses or here in the second set? The second set, look what's going to happen. 3 times 1 is 3, correct? What's 3 times 3x? 9x. What's 1 times x? 1x. My signs are the same. They're both going to be pluses. If I add those together, what do I get as my middle term? 10x. That's how you can trial and error that problem. Okay? I don't care which way you do it. But sometimes it's just as easy to do it that way. Trial and error. 3x plus 1 times x plus 3 over. Now what? Cancel out the quantities, right? Am I going to do this? No, you cancel out the quantities. That's why I say quantities. What's your final answer? X plus 3. How many of you had x plus 3? Hands up. Questions? Any questions at all? All right. Changing gears. You got to simplifying down? Hey, do you realize why we factored first? If you can't factor, is this going to be easy? Nope. This is not going to be easy for you. You have to know how to factor. Probably one of the most important, if not the most important, skills you learn in an algebra class. So let's multiply and divide. Well, let's multiply. Go back to what we know. Something easy. Multiplying 1/2 times 3/5. What do? Say it again. Do we cross multiply? No, we go straight across. Multiply straight across. All right, when we do that, we get 3 over 10, right? All is well with the world. It doesn't have to reduce, correct? But what happens when you get something like this? That's bad. All right, now Tyler's back there giving me the sign language for do the thing, right? I don't know what it's called either, okay? But I understand that sign language. We've got to figure out, doesn't 8 and 12 have something in common? 4. How many times will 4 go into 8? 2. How many times will 4 go into 12? 3. And then 2 goes into 2. 1 time, 2 goes into 24. 12 times. Y'all remember doing this? And now we're ready to straight multiply across right on. 1 times 3 is 3. 2 times 12 is 24. And then daggone it if we can't do what again? Now we can simplify again to what? 1 who? 1/8. That's right. Now what did we actually do? We simplified within our problem before we simplified at the end. Okay? And there's always, why can't there just be one way to solve these problems? Because that would make life too easy, right? Here's what you need to know. What are we going to do when we have these algebraic expressions, when we have a trinomial over a binomial, times a polynomial over a trinomial? What are you going to do then? Do you think you're going to multiply straight across and then reduce? Or are you going to simplify and then see what happens? You're going to simplify because it's going to make it easier on us. So here we go. Let's check this out. If we have, put this down, reminder. And I call it cross-canceling. That's what I call it, Tyler. It's in my notes. I put it in there this morning. You can, and I don't know if that's technical or not, but you can cross-cancel factors vertically and diagonally but not horizontally. You can cross-cancel factors vertically or diagonally, but absolutely not if they're side by side, right? Cross-cancel, that's our technical term that we're looking for. So you ready for this? You guys just watch the video. We're now at minute 20. So go, I don't know, about minute 10 to 20, and that's probably what you've missed. All right, here we go. Might as well start out with something fun. W squared minus 11W plus 24 over W squared minus 18W plus 80 times W squared minus 15W plus 50 over W squared minus 9W plus 20. What the world? Bless you. What are we going to do? We're going to unfoil everything. All right, so here we go. Let's unfoil this top fast here. I got W. I need two factors of 24 that when you add give you 11. 8 and 3. Are my signs the same or different? Same. They're both going to be minuses. All right, let's go with the bottom there. W. Two factors of 80 that when you add give you 18. 8 and 10. My signs the same or different? Same. They're both going to be minuses. Y'all with me? Yes or no? Okay. Go to the next side. W. I want everybody to tell me two factors of 50 that when you add give you 15. 5 and 10. Same signs. Both going to be minuses, negatives. And the denominator. W. Two factors of 20 that when you add give you 9. 4 and 5. Signs same or different? Same, both going to be minuses. All right. This is when, if you have different colors, it makes me happy. Remember, we can cross-cancel vertically or diagonally, but not across, not side by side. So let's get to canceling. W minus 8 has got to match where? Right underneath it. That's legit. That's legal. Okay? Remember, I'm canceling quantities, not terms. W minus 3, does it have anything it can cross-cancel with? Nope. How about W minus 5? Yeah, look at me with my different colors. Isn't that neat? How about W minus 10? Yep. Here and here, right? Now, what's left? W minus 3 over W minus 4. Oh, I can cancel out my W's, right? Why not? They're holding hands. They're holding hands. That's what I heard all last semester. They're holding hands. And that's right. Don't be messing with my 3. Don't be messing with my man. Okay? I've seen y'all in the hallways. I know how you would be. All right, questions on that. Facile or difficile? Facile. Muy fácil. See? See. Here we go. Here's another one. 3x plus 6 over 7x minus 7 times 14x minus 14 over 5x plus 10. Go to it. Do that one yourself. You don't need me to hold your hands. All right? Tell me what to do. All right. Good. Okay. How many of you had that much right? Hands up. All right. Get to canceling. Cindy, cancel. Cancel everything out for me. Right? X plus 2, x plus 2. Anything else? X minus 1. All right. You said that, and then I looked at Kaylee, and Kaylee said x minus 1, right? Okay. And then Cindy, what'd you say? I got you. No, maybe not. What'd you? Okay. When you do that, that is not taking out the greatest common factor. You're taking out a factor, but not the greatest common factor. Okay? All right. Can I do anything else? What else can I do, Kelly? 7 and the 14. 7 goes into 7 one time. 17, 7 goes into 14 2 times, right? Anything else? Nope. All right, so what now? Just multiply across. 3 times 2 is 6. 1 times 5 is? Should have done that problem first, shouldn't I? That was like a baby problem. Facile, difficile. Cool? Yeah? All right, so what happens? Let's do this one. No questions at all. All right. Mark your notes, those of you just coming in, like minute 25. That's where you just came in. So you'll have to watch probably, I don't know, minute 10 to 25. What's this mean right here? Put a star by this one. Why do you think I want you to put a star by it? Oh, it's got a square, it's got a cubed, it's got a little bit of everything, doesn't it? What do you think's going to happen here? Zach, what's going to happen in that numerator? Say it again. Difference of squares. Can I just leave it as 4 minus x squared and not freak out because my variable is not first? Can I still factor it if it's not in descending order? Yes, you can. Yes, you can. What's the square root of 4? 2 and 2. What and what? Minus x plus x, right? It looks weird. I know it does. But it's all right. Just chill. It's okay. Now, what's up with that x cubed minus 8? What's that, folks? That's the difference of cubes. So how are we going to break that down? That's a binomial times a trinomial. All right, here we go. What's the cube root of x cubed? X, the cube root of 8 is 2. All right, this thing squared is x squared. This thing squared is 4. How do I get my middle term? X times 2 is 2x. And its difference, it's subtract. So it's minus plus plus, right on? All right, now, why did I put a star by this problem? Kelly, why did I put a star by this problem? What can I factor out? What looks similar? It's like they're cousins. Y'all know they're cousins here at this school that could pass almost for brother and sister, or maybe sisters or brothers, right? But it's like they're cousins. Doesn't it look like it? 2 minus x and x minus 2. Doesn't that look similar to y'all? Okay? So I think, I really in my head think kind of like cousins. So what am I going to do to this top, Kelly? Take out a -1. Factor out a -1. That's why I told you yesterday, I said you're going to see it again. This factoring out a -1 is important stuff. I don't know why it's all over this book, y'all. I don't know why, but it is. So let's factor out a -1. -1 times what gives you +2? -2. -1 times what gives you -x? Plus x. Oh, now I'm happy. Why am I happy now? Because what can I do to negative 2 plus x? For me, I can rewrite that thing. And I know I'm going to have to rewrite it, and some of y'all are like, why is she rewriting that? Can't she just know? Yeah, I can. But if you had to just go by my notes and not hear my voice telling you how to do these problems, you ought to be able to follow my work step by step. You ought to be able to follow your own work step by step. Now what? Anything going on here? I can cancel out my x minus 2's, can I? What am I going to do with that negative 1 that's just sitting out there? Just leave it there. Bring it down. It's part of our answer. Is it okay to write 2 plus x? Yes, it's okay. Would it also be okay for me to rewrite 2 plus x as x plus 2? Yeah. Why? Commutative property of addition. Am I done? Do what? Can't factor that trinomial. Why? Well, because do you know two factors of 4 that when you add give you 2? No. Remember that trinomial, when you break down a difference or a sum of cubes, that trinomial is done. It's prime. You can't do anything with it, okay? Is it okay to leave that negative 1 there and not distribute? Yeah, don't distribute it out. Then you're just chasing your tail again. Don't do that. Questions? Yeah. No, you don't forget about that negative 1. That negative 1's got to be there. Okay?
Any current or former patient of Dr. David Jones, orthodontist in Martinsville, to report to the DM for a group picture.
Like half the class. See y'all. Yeah, go ahead. Go ahead. Go ahead. All right, here we go. Write this one down, guys. What's different about this problem? It's division. You, go ahead. Watch the rest of the video. It's all on the homework page. Okay? We're dividing fractions, right? Okay. Say it. Copy, change. Copy, change, change. I like copy, change, flip better because it tells you what to do. Write this down. Copy, change, flip. What are we actually doing? Multiplying by the reciprocal. Okay? We're actually multiplying by the reciprocal. That's what we're doing. So I'm going to break this down. Give me 2 factors of 8 that when you subtract give you 2. 4 and 2 plus 4 minus 2. Right on? Right on. 2 factors of 3 that when I add give me 4. 3 and 1 plus and plus. Yes? All right. I'm going to go ahead and multiply by, what's going to go on top here? 3 times the quantity of what? X plus 1. I'm skipping a step, y'all. You better mark this on your calendar. I just skipped a step. Whoop, whoop. I never do that. What about x minus 2? Leave it. It can't do anything to it. It's simplified. Now what? Mark them out. Mark what out, Morgan? X minus 2, X minus 2, anything else? X plus 1, X plus 1, anything else? Ooh, the 3s. That's what I'm always wanting y'all to go, no! Don't you dare do it! No! This is a monomial. This is a binomial. Don't do it. Do not. Don't. X plus 4 times 3 over X plus 3. Oh, come on now. Can't we cancel those 3s? Why not? It's against the law. I'll give you a ticket if you do. You'll go to jail. Nope. Why? What property? We've said it 300 times already in the last 4 days. What property? Commutative of? Do I need to multiply the 3 to the top? Nope. Leave it alone. Questions? Happy? Happy, happy. Right. So why don't? I'd rather see the factors than everything multiplied back out. How do you feel? Good and groovy? MC, good and groovy? Yeah? Okay. All right, here we go. Here's what you're going to do for me. We're going to add and subtract tomorrow. I want to give you time to work on homework. Page 534. I know. Yep. Hey, I do want you to try this one, though. I do want you to try that. Yep, I do want you to try 77. Now, let me tell you something. Stop talking, listen. 77 is an adding and subtracting. If you remember from Algebra 2, this is going to be a piece of cake. If you don't, then that's why we're only doing one of those. Got it?